Thank you for joining this lesson. We are going to discuss gradient and equations of straight lines. This is a grade 9 mathematics and also form 2 mathematics. Remember, the concept on gradient and equation of line is examinable in both the Kenya Junior Secondary Education Assessment and also in the Kenya Secondary Certificate of Education, Kcse. So for students or candidates preparing for these exams, you are supposed to follow up with this program. Remember to subscribe, remember to share, remember to even invite friends to this broadcast. Our consultation line remains 0704 15 3366. So feel free to reach out through that number. Gradient. Let's begin by having an introduction to what gradient is. A technician is to climb to the top of a 3-meter wall to repair. This is shown in the figure below. Look at this. Now we are having a wall here, which is 3 meters. Then we have 2 ladders. Ladder AB, which is 2 meters from the vertical wall. Then another ladder CB, which is a bit far from the wall, and that is 2.5. So we are told to let AB and CB be 2 ladders leaning against the wall. If he asks the option of using either ladder, which one will be easier? Let us look at how steep each is. The distance from the feet of the ladders to the wall are 2 meters and 2.5, as just I have said. If the technician uses ladder AB, he will have to move through a horizontal distance of 2 meters. For every 1 meter moved horizontally, the corresponding vertical displacement is 1.5, or simply 3 out of 5. So for every 3 in the vertical, there is 2 meters in the horizontal, in other words. So the ratio of the vertical distance to the horizontal distance is simply what we call the measure of the slope, or simply the gradient. Now for the other ladder, it will be 3 out of 2.5, which becomes 1.2. It is good for you to note that the higher the steeper, or the ratio is higher when the ladder is steeper. When the ladder is steeper. So the ratio is higher when the ladder is steeper. That is why there is a steeper gradient for AB than for CB. So the ratio of vertical distance to horizontal distance is the measure of steepness or the measure of slope, and is known as gradient. So the basic definition of a gradient is the ratio of vertical distance or vertical displacement to the horizontal displacement. The same can be done for lines. We can consider an example of line OP. Line OP, whereby we have O to P. You know P is a 4-3 coordinate, 4-3. Therefore, 4 units in the X and 4 units in the vertical axis, and that means a gradient equivalent to 3/4, which can also be narrowed down to the decimal 0.75, which is not a must. It can be expressed as a fraction or even a decimal. Okay. Find the gradient of line BP. The gradient of line BP. We can look at that. The line must have been drawn. Look at line BP, whereby it has a points B 29, then A 0.3. We can have other lines. We can have other points like a P on the same line. It's a straight line. So if we are to consider from A to B, the change in the horizontal we are moving from x being 0 to x being 2. So there are 2 units here. But vertically, we are having this is 3. Then finally, we are moving to 9. So from 9 to 3, there will be 6 units here, or 3 to 9, 6 units. So the gradient, which is abbreviated small letter m, will be given by 6 out of 3, 6 out of 2, which is narrowing down to 3. So the gradient is 3. So let's now come up with a general way of expressing gradient, because gradient is change in y coordinates out of change in the x coordinates, the corresponding. Then if we have a line passing through P and Q with those given coordinates, then we can say the gradient will be given by, when we take y2 minus y1, that is change in y, out of x2 minus x1, that is change in x, we'll get the gradient. But this does not restrict us in the coordinate that we will begin with. It can even be y1 minus y2 out of x1 minus x2. This will give us the same gradient, the same gradient. We can get back to the example up there and say, if we use change in y as 9 minus 3, then 2 minus 0 for the x, this will be 6 over 2, giving us 3. But if we start again with the first y here, 3 minus 9, and we also take 0 minus 2, you find that we have negative 6 out of negative 2. You know, the negative will cancel out. Then 6 over 2 becomes 3. So we can begin with any coordinate. You can just begin with any coordinate. So that is the general formula we can use to calculate gradients, unless other information is given, because gradient can be found using very many approaches for a given straight line, depending on the provided information. Look at this. If an increase in the x coordinate also causes a corresponding increase in the y coordinate, the gradient is usually positive. Gradient is usually positive. That is something you're supposed to note. So a positive gradient, like the line here, x1 and x2, you discover x2 is greater. Then from y to y2, y2 is again greater than y1. So increasing the x value has led to a corresponding increase in the y value. Such a line will be having a positive gradient. If an increase in the x coordinate causes a decrease in the value of the y coordinate, then such a gradient will be negative. Such a gradient will be negative. I'll be giving examples of such lines as we look at the diagrams in this book. If an increase in the x coordinate, there is no change in the value of y coordinate, the gradient is 0. In other words, these are the horizontal lines. Horizontal lines. So for an horizontal line, the gradient is usually 0. Then finally, for vertical lines, the gradient is usually undefined. It's not defined, it's infinity, because there is no change in the y. There is no change in the x. So without change in the x, that means we are dividing by 0. The answer will be infinity. Look at this equation. Look at this line. P is here, Q is here. We even have other coordinates here, which can also be identified. The line is sloping. The line is sloping from top left to bottom right. So automatically we expect a negative gradient. Gradient is letter M. If a line is moving that way, it will have a negative gradient. Then if a line is sloping all the way from bottom left to top right, This one will have a positive gradient. A positive gradient. And now, if a line is horizontal, for example, a line that passes through 4, a line passes there, it will have a gradient equivalent to 0. And for vertical lines, let's say a line passes through 2 and it is vertical, the value of the gradient here is going to be undefined, or rather infinity, because anything divided by 0. So this is the general now overview of all the gradients. A gradient can either be negative if the line is this way. A gradient can be positive if the line is this. A gradient can be equivalent to 0 if the line is horizontal. And a gradient, again, can be up to infinity if the gradient, if the gradient can be up to infinity if the line is vertical. So if, for example, now we calculate gradient for the provided line here, we have to take change in y over change in x from 3 to 1. So 3 minus 1 out of change in x, negative 3 minus 1. Now this will be 2 over negative 4, negative half. See, the gradient is negative half, and how the line is behaving, it will give us a negative gradient. So the negative was already expected. The negative is already expected. Find the gradient of the line. Is an example. Find the gradient of the line. Okay. Later we will be concluding that the value just behind x is the equivalence of the gradient, but at this stage we can even work out a table of values, x and y, so that with the values we can use them to determine gradients. Remember, we need only 2 coordinates. When x is 0, for example, and we substitute in this equation, then you shall discover that when x equals to 0, the value of y becomes 2. When you substitute y equals to 3 by 0 plus 2. Then when x is 1, we substitute 1 at this point, and it will be 3 times 1 plus 2, which is 5. So the 2 coordinates are 0, 2, and 1, 5. So to get gradient, we need 2 minus 5. Divide by 0 minus 1. So I'm getting negative 3 out of negative 1, which will be 3. Yeah, the gradient will be 3 at the end of the day. The gradient is 3. We can pick any coordinates. In the figure below, name the lines whose gradient is positive, negative, 0, and defined. Positive gradients, L2, L3, L4. We know that when the line is horizontal, the gradient is equal to 0. Therefore, L5 and L6 will have a gradient equivalent to 0. Then the line sloping from top left to bottom right, and that is L, is it a L1 and L8 or L7? This can be L7. Yeah, L7 and 8. They have a negative gradient. And finally, L1 will have a gradient which is undefined because it is a vertical line. So that is how we can generalize all gradients. I hope you get that point. For each of the following pairs of points, find the change in the y coordinate and the corresponding change in the x coordinate. Hence, find the gradient of the lines passing through them. So the gradient of a line passing through 2 coordinates, A, B, we need to find change in y out of change in x. 6 minus 3 out of 5 minus 2. This will be 3 over 3, simplifying to 1. Change in x. I want to emphasize that you can begin with any coordinate, because if we pick 3 minus 6, divide by 2 minus 5, we will be having negative 3 out of negative 3, and this will still simplify to positive 1. So the gradient will just remain the same, regardless of what you begin with. regardless of the coordinate you choose to begin with. So you can now proceed with the others. Give me the gradients. Look at this other question here. Find the gradient of the lines marked L1, L2, and L3 in the figure here. I will deal with only one. Let me choose this line L3, which is even having a negative gradient. So I just need to come to this graph and I pick two coordinates which are lying on the line. Two coordinates on the line can be one coordinate is here. Let me use a blue color. One coordinate is here. That is a -4, 4. And another coordinate is here, which is -1, 2. -1, 2. Those are the coordinates of the given line, some of the coordinates. So any fixed coordinates can help us to get the same gradient. So when I work this one, I expect you now to proceed with the other lines, L1 and L2, which are having positive gradients, and get us the gradient. So I need to pick change in y. So 4 minus 2, change in x, -4 minus -1. Must be very careful at that point, minus -1. So 2 out of -3, yeah, because this will be -4, then this becomes a positive now. -4 plus 1, -3. So this is -2 thirds, -2 thirds, yeah, -2 thirds. So you can now check the others. Find the gradient of the lines passing through, yeah, there. Find the gradient of each of the following lines. Now for these lines, I have said that at an advanced level, you will be able to pick the gradient just from here. Instead of getting a table of values, then calculating gradient using change in y over change in x, you can simply pick the gradient from that point. This equation is not in the right format, which can help us to pick the gradient such a way. But this one, you can just pick it as -2. Here, gradient such way. But now, this exercise is meant to help the students to come up with a table of values, the concept of Form 1. Table of values, then use those coordinates to calculate, to your calling, the gradient. So come up with a table and calculate gradients. But now we have to advance to a different thing. Yeah, the exercise, you can just continue with it. Now we can check on what the equation of a line is. Depending on what has been provided, the equation of a line can be calculated using several approaches. And as we continue learning here, please remember our program here, whereby you can get airtime of any amount for any network, as long as the network is working in Kenya. You go to your M-Pesa menu, Lipa na M-Pesa, the pay bill number, which is the business number, 737356. The account number is that particular phone number that you'd like to purchase airtime for. So you enter the pay bill number. Then now for the account, it is your own Safaricom line, the Airtel line, the Telcom line, depending on the line you are purchasing airtime for. Now you use it at the account. Then you proceed with the amount. You finish up with the transaction, and the airtime is going to reflect instantly. So please use that approach. Invite friends. 737356 is a simple number which can be memorized by any of us. Remember to subscribe. Remember to give a comment. Let's know where you are following us from. Let's know whether you are getting us clear. We really appreciate your time. Thank you for joining Shifting Grades. We are streaming live from Shifting Grades Online School. Let's know where you are listening us from. When you are given 2 points, you can calculate the equation of a line. And how do you proceed? For example, find the equation of the line through point A, 1, 3, and B, to 8. So the first thing you do is to find gradient. Find gradient. We said the abbreviation of gradient is small letter m. Then now use gradient m, one of the provided coordinates, say AB, and let another coordinate be xy. Then now express the gradient using those coordinates. Express the gradient. Through this way, you can even organize the equation in the form y equals to mx plus c. You can express the general equation to this format. Later, we will be knowing what m is and what the value of c is. Look at this example so that we may save our time. I want to go directly to the example which has already been provided. The gradient is going to be 8 minus 3 divided by 2 minus 1. Then we will be having, this is a 5 over 1, which is simply 5. So the gradient is 5. Now we use 5 and another coordinate, xy, and one of the provided coordinates. Actually, I'm not supposed to say one of the provided coordinates. I should say any of the provided coordinates, because any will give us the equation. So we express gradient, which is 5, using change in y over change in x. So y minus 3 out of change in x, x minus 1. Across multiplication, remember 5 is over 1 automatically. So across multiplication will give us y minus 3 equals to 5x minus 5. So y, to remain with it here, equals to 5x minus 5, and y becomes positive, minus 5 plus 3 to be negative 2. So this is the equation of that particular line. Equation of that particular line. Okay. Equation of that particular line. I can say this, if we pick the same gradient, then we choose the second coordinate, y minus 8 divided by x minus 2. Across multiplication will give us y minus 8 equivalent to 5x minus 10 after cross multiplication. To remain with y, we should talk about 5x minus 2, because negative 10, this one becomes positive 8 now, it should be negative 2. So that is how we should get the equation of a straight line. Equation of a straight line. After it all, after rearranging, you discover that the value of gradient is at this point. Gradient was 5, the coefficient of x is also 5, but we'll be summarizing the conclusion later in this broadcast. You can be advised to give us the equation of a line, but now what is provided is the gradient and 1 point. This is now simpler, because with the gradient of 3 and a point where the line passes 1, 5, we can just let another point be xy, and we express our gradient of 3 as change in y, y minus 5, over change in x, x minus 1. Across multiplication is going to give us what? Y minus 5 equivalent to 3x minus 1. Yeah, 3x minus 3 after cross multiplying now by 3 here. 3x minus 3. So remaining with y, we will have 3x, then minus 3 plus 5 will be positive 2. See now, at the end of it all, the value of gradient, which is 3, is being found as the coefficient of x in this general equation. And therefore, this means we can draw certain conclusions. Linear equations in the form, equations of lines is what we call linear equations in the form y equals to mx plus c. Y equals to mx plus c. We're supposed to know that when equation has been arranged in this format, we have x and y being variables in that they can change as you move along the line. The coordinates of x and y are changing throughout. What about m and c? These ones are constants. They don't change. They are constants. M and C are constants. Therefore, in the equation up here, for that particular equation, the value of 3 does not change. It remains a constant. The value of 2 does not change. It remains 2. So what are these constants? What are these constants generally? The equation y equals to mx plus c. M is the gradient, or simply the slope, while c is the y-intercept. Now, I'll be telling you what y-intercept is. This is the point where a straight line will cut the y-axis. If a line is plotted, along the x-axis, along the Cartesian plane, that is, a line like 3x plus 2, y equals to 3x plus 2, the line will cut the vertical axis exactly at the point where x is 2, exactly at that point. So that is what we call the y-intercept. So the y-intercept is the point where the line cuts the y-axis. If, for example, we talk about this equation, we can obtain from this equation y-intercept and gradient without calculating, without using the table of values to find gradient. We can just rearrange the equation. So we remain with y here, 3y equals to, 4x will be starting here and it will be negative. Then there is already a negative 8. So to remain with exactly y, we'll have 4 over 3x minus 8 over 3, because I'm dividing by 3 through. So the gradient for this particular line is exactly negative 4 over 3. You just pick it as the value of m, or other, the coefficient of x. So whatever is behind x, the coefficient of x gives us our gradient. So we go to gradient. Then the value of c, which is y-intercept, is going to be negative 8 over 3. So in case the line is drawn, it will cut the vertical axis exactly at negative 8 over 3. Something that you're supposed to understand. Yeah, something that you're supposed to understand. Now look at this. You have some equations here. L1, the format we want. We extract the value of m and c. We conclude what the gradient is. I will add here, in such a line, we should be able, I'm trying to save on time so that we may not go to another subtopic, which is the y-intercept. We can talk about the y-intercept of that particular line, the y-intercept. Therefore, the equation is 2y equals to x plus 6. When we make it the format y equals to mx plus c, then we need to divide by 2 throughout, so that we remain with y equals to half x plus 3 when x is divided by 2. So m is half, the coefficient of x. C, the constant, is 3. Therefore, for this particular line, the gradient is half and the y-intercept is 3. For the other line, we divide through by 3, so that the coefficient of x, 4 over 3, the constant 5 over 3. Therefore, the gradient will be 4 over 3 and the y-intercept will be negative 5 over 3. So in the case the line is plotted, it will exactly cut the vertical axis at negative 5 out of 3. Let's talk about 2y equals to 7 minus 5. We have to rearrange so that the part with x begins. So negative 5 is the one to start here. But now remember, we are dividing by 2 or through. So negative 5 over 2, x plus 7 over 2, whereby m is negative 5 over 2, 7 over 2. So the gradient is exactly going to be 2.5 negative, and the y-intercept c is going to be negative. Not negative, sorry. This is already positive 7 over 2, 3.5. Positive 3.5. 7 over 2 gives us 3.5. So we can extract y-intercepts of lines and the gradient of a line from the equation without even calculating by simply rearranging. Yeah, we just rearrange the equation. In each case, we notice that the gradient equals to the corresponding value of m. If we put the equation in the format, we can easily tell the gradient of the line. So when a straight line is put in the form y equals to mx plus c, we can easily conclude on the value of gradient, which is equivalent to m. So we can extract the gradient directly from the equation. Find the gradient of the line whose equation is, look at this. So we need to remain with 3y here, and 6 becomes positive, 7 becomes negative. Yeah, then to remain with y, we divide by 3. With this kind of an equation now, we can say that gradient m equals to 2. The y-intercept c equals to 7/3, negative 7/3. So what are we calling the y-intercept? I talked about it, but I repeat it because it is here. Consider the following equations. These are the equations. For each line, find the value of y when x is 0. So for us to find y when x is 0, for the first line, we substitute 0 here, and the y automatically becomes 2. We substitute 0 here, the value of y becomes 3. We substitute 0 here, the value of y becomes negative 4. Therefore, the constant c is usually the coordinate of y when x is 0. The value of y when x is 0. And for this particular line, it means this is the point where the line is cutting the y-axis, because x is 0 on the y-axis. X is 0 on the y-axis. So if we talk of 0, 2, for example, which point is that? Along the Cartesian plane, the y-axis, it means the line passes through point 2, and that is the y-intercept of the line, because the line will pass this way, the y-intercept of the line. So the y-intercept can be interpreted from the same equation. So with this kind of an equation, we need to know that this line will cut the y-axis at point 0c. So the value c is called the y-intercept. The y-intercept. And for the above equations, we have 2, 3, and negative 4. 2, 3, and negative 4. Can we also talk about something else? If a line passes through points A0 and 0B, then A and B are called the x-intercept and the y-intercept, respectively. X-intercept is the point where the value of y becomes 0. That's why we have A0. Y-intercept is a point where the value of x becomes 0, 0B. So the value of A is x-intercept. The value of B is y-intercept. The equation of such a line can be given by x over A, y over B is equivalent to 1. And from that, we can extract again coefficients. We can extract the intercepts directly from this kind of an equation. This format is called the double intercept form. The double intercept form. So you can be taught to write a certain equation and express it in the double intercept form. You will ensure that you have 1 on one side. Find the equation of a line. Look at this now. Look at how things are going to be simple now. Find the equation of a line whose x-intercept is -3 and y-intercept is 6. X-intercept -3 means the coordinate is -3, 0. Y-intercept 6 means 0, 6. That is what it means. So we can get gradient 6 minus 0. 0 minus -3. This will be 6 out of 3, giving us a gradient of 2. Now with a gradient of 2, m equals to 2. C equals to the y-intercept, which is 6. Y-intercept is 6. So the equation will be, the general equation is mx plus c. M is 2. C is 6. So we feed those values automatically. This is now the equation for that particular line. You just fix them directly. Just fix them directly. Even when an equation has been drawn, even when equations are drawn, you can do the equations with a lot of convenience, with a lot of ease, without struggling, because the y-intercept can be read. Because the y-intercept can be read directly. Yeah, as we look at several examples, you see here, for the following straight lines, determine the gradient and the y-intercept, which means the equation just needs to be arranged. Look at equation 1, 3y equals to 7x. So we need y equals to 7 over 3x. There is nothing we are adding here. That means gradient is 7 over 3, and y-intercept is not there, or rather, the line passes through the origin. Y-intercept is the origin. The line will just pass through the origin. Because we have 0 here, it will pass through the origin. But looking at equation B, we need to make it y equals to, we divide it through by 2 here. So this becomes 3x, and 1 becomes a half, or 0.5. Therefore, the gradient shall be 3, and the y-intercept automatically 0.5. Yeah, automatically 0.5. Remember, for individualized institutions, you can reach us through 0704 15 3366. Yeah, remember this. It's our number. You can continue with the upper part of the equations and find all those. Find the equations of the lines with the given gradients and the points. So we have a gradient and 1 point. Just need to let another point be xy, and you express. We have already done an example. We have already done an example. We have already done an example. With the drawn lines, look at the first line, L1. I'll do L1, then I leave you to proceed with the other lines. With L1, I have some fixed coordinates that I can rely on. Fixed coordinates can be a coordinate like this, 2, 1. Another coordinate on this particular line can be 4, 3. 4, -3, sorry. So how do we get gradient? -3 minus 1, change in y, out of change in x, 4 minus 2. So I'll be talking about -4 over 2, which is -2. So the gradient is -2. And naturally, depending on how L1 is sloping, we can just get the gradient without struggling. This equation now can be found with a lot of ease. We need to take the gradient, -2. Then we use another coordinate, xy, together with one of the provided coordinates, like 2, 1. So y minus 2, y minus 1, sorry. Yeah, change in y minus 1, and x minus 2. Cross multiplication will give us y minus 1 equals to -2x, then +4. Yeah, +4. So y equals to -2x, +5, because this will be positive here. So with this equation, we can also say that because general equation equals to y equals to mx plus c. This is usually gradient, and this is usually y-intercept. So alternatively, after getting the gradient of -2, we would have gone to the line because it has already been drawn for us. It has already been drawn for us. So the value of m is -2. So y equals to -2x plus, where does the line cut the vertical axis? That is 5, between 4 and 6. So we just add 5 automatically. So the same equation can be gotten with a lot of ease, without even struggling. You get the line's equation at all. Yeah, so that is it. X and y intercepts of a line are given below. Determine the equation of the lines. We said the line can be given in the double intercept form. Double intercept form meaning if we take the value of x over -2 and we add the value of y over -2, we will be able to get 1. Because we don't have to divide by a negative number, this will be -x over 2 minus y over 2. This is equal to 1. This is called the double intercept form. The double intercept form. If not the double intercept form, kindly notice that this can be changed to a coordinate -2, 0. This can also be changed to a coordinate 0, -2. Then you get gradient. You get gradient by taking -2 minus 0, then 0 minus -2. So this will be -2 over 2, which is -1. The gradient is -1. So if the gradient is -1, y equals to -1x plus the y-intercept, which is a negative. So the equation can also be this way. So we have 2 formats here, the double intercept form and also the double intercept form, also y equals to mx plus c. And you proceed with the other lines now. -3 and 4. You can use them as coordinates to come up with the gradient, then the equation, and also express the equation in the double intercept form. Kindly embrace the 2 formats. They are really going to help you. The 2 formats shall help you. Thank you so much for following. Remember to just comment. Let's know where you are following us from. Let's know whether you are benefiting. If you feel that it is good to appreciate the work being done in shifting grades, kindly use the M-Pesa number on the screen, 0704 15, then 3366, a very simple number which you can master. 0704 15 3366. That is the number you can reach us through. The graph of a straight line. Okay, drawing a straight line now has become very easy nowadays because we have the concept of intercepts. Draw the graph of a line passing through 0, -4, and has the gradient of 2. And has the gradient of 2. What does it mean by this coordinate? It means for this particular line, the equation can be written directly. Gradient is 2, so 2x. And the y-intercept is -4, so -4. This is the equation. This is now the equation. With the equation, we can now conclude a few other things. And what are these other few things? We can talk about some coordinates for us to plot the line. Yeah, some coordinates for us to plot the line. So one of the coordinates is here. So we can get another coordinate. That coordinate will be when x equals to 0, y is -4. What about when y equals to 0? X will be what? When we substitute y with 0, the equation will be 0 equals to 2x minus 4. So 4 becomes positive here, 2x. The value of x will be 2. So when y is 0, x is negative 2. That is called the y-intercept. So the coordinate will be 2, 0. So we have the coordinates of the intercepts, 2, 0, and 0, negative 4. So you just need to connect the two intercepts. You just need to connect the intercepts. I'm doing a sketchy drawing of that line so that you may know that it is very easy for you to come up with a graph of a straight line. A graph of a straight line. So are we talking about x-intercept being 2 and y-intercept being negative 4? Then the line can just go through those 2 points and you'll be having your line. So the graph of a line can be drawn with a lot of effectiveness following the intercepts. You determine where the line cuts the y-axis. You also determine where the line cuts the x-intercept. X-intercept, y-intercept, they help us to draw straight line graphs. Yeah, the graph is already there. So we can draw the line passing through these given points, draw the lines passing through the given points, and there are gradients. Check 0, 3. Check also gradient 3. So where is the line? Y equals to gradient is 3 and y-intercept is also 3. With this gradient, with this kind of an equation now, we can also get the x-intercept. What is x-intercept? The value of x when y becomes 0. The value of x when y becomes 0. So 0 equals to 3x plus 3, negative 3 equals to 3x. X equals to negative 1. So the coordinate is negative 1, 0. The other coordinate is 0, 3. With these two coordinates, you can connect them and give us a very straight line. Very straight line. We are remaining with some 2 more concepts on equations of straight lines. On equations of straight lines, let's talk about perpendicular lines, and later we'll be concluding with parallel lines. For perpendicular lines, if 2 lines are perpendicular, this one you should even write somewhere. If 2 lines are perpendicular with gradients M1 and M2, then M1 multiplied by M2 gives us negative 1. So the product of the gradients of 2 perpendicular lines is usually negative 1. With that language, you'll be able to determine equations for perpendicular lines, and you'll be able to work out several problems in this topic. Look at this. These are pairs of perpendicular lines. Yeah, pairs of perpendicular lines. When you extract the gradients, you notice that gradient 1 times gradient 2, you're supposed to get negative 1. If the product of the gradients of 2 lines is equal to negative 1, product of 2 gradients equals to negative 1, then the 2 lines are perpendicular to each other. Which of the following is perpendicular? Following lines is perpendicular to the line y equals to 4x plus 2. Y equals to 4x plus 2. Y equals to 4x plus 2. You know the first gradient is 4. We just pick it here. What about the second gradient? I'm having the second gradient as negative a quarter, or I express the line plus half. So gradient 2 equals to negative a quarter. What if I multiply 4 and negative a quarter? Am I not getting negative 1? Yes. Therefore, L1 is perpendicular to the provided line. Why? Their product is -1. Look at the second equation. If I rearrange it, it will be y equals to, this goes to the other side, -4 plus 6. So this first gradient was 4. The second one, M2, is -4. Product of M1, M2, I'm getting 4 by -4, -16. Therefore, they are not perpendicular. Whenever you multiply gradient of two different lines and the product is exactly -1, those two lines are perpendicular to one another. Yeah, those two lines are perpendicular to one another. Without drawing, determine which of the following pairs of lines are perpendicular to one another. So you just need to compare the gradients to -1/2, getting -1 perpendicular to one another. Very good. A third, -3, -1 perpendicular. 2, -2, getting -4, not perpendicular. So you can determine pairs of lines which are perpendicular to one another by simply checking the product of the gradients. Now look at this. The commonly tested format of this concept. The commonly tested format of this concept of straight lines. I just need to look at this. Determine the equation of lines perpendicular to the given lines and passing through the given points. So a line perpendicular to this one, and the line is passing through 3, 2. So y equals to 5x. I'm taking them to the other side, -3. This becomes 5x. This becomes positive. It's +3, so -3. For this perpendicular line, the gradient equals to 5. Now I need to work with the gradient of this other perpendicular line must be giving us -1. So 5 times gradient 2 that we don't know, we are supposed to get -1. So M2 is going to be -1/5. So we have gradient 2 and we have a line, we have a point where the line passes. If we have a point where the line passes, then this equation can be determined. So we say -1/5 equals to y -2, x -3. Across multiplication will give us 5y -10 equals to -x +3. I'm cross multiplying by -1 and here by 5. So 5y equals to -x plus 13. So that we talk about y equals to -1/5 x plus 13 out of 5. Yeah, plus 13 out of 5. 13 out of 5. So in this particular case now, we have gotten our equation. We have gotten the equation. Part B. In part B, we are told that the line is perpendicular to this one and is passing through -3, -4. So the first line, y equals to, we begin with -7x, then +8. Gradient 1 is equivalent to -7. So gradient 2 must be equal to 1/7. So that 1/7 by -7 becomes -1. 1/7 times -7 becomes -1. So now with this gradient, we need to express it now. 1/7 equals to change in y. The coordinate is here. Change in y minus -4. Out of change in y minus -3. Therefore, 1/7 equals to y plus 4, x plus 3. Cross multiplication 7y plus 28 equals to x plus 3. So 7y equals to x minus 25, because 3 minus 28 is negative 25, right? The value of y will be 1 over 7x minus 25 out of 7. So you can now work out similar questions. In the effort to find some similar questions, I had to focus on the Kcse 2024 examination, mathematics paper 1 and 3, whereby the question is exactly testing such a concept. We are told is a straight line L1 whose equation is y equals to 2 minus a third x meets the y-axis at Q. Another straight line L2 is perpendicular to L1 at Q. The same coordinate. Find the equation of L2 in the form y equals to mx plus c. Look at this. Equation 1, y equals to, I begin with negative a third x, then I add 2. You see, now I can say that the value of gradient is negative a third for line 1, m1, negative a third. And the y-intercept c equals to 2. Y-intercept can be written as a coordinate, whereby it is coordinate q. Where the line cuts the y-axis is coordinate q. So coordinate q will be 0, 2. That is what you're supposed to know. 0, 2. Now there is another line, L2, perpendicular to L1. So if they are perpendicular, then gradient 2 can also be determined such that when we multiply it by negative a third, we get negative 1. And that line is automatically going to be positive 3. The line is going to be positive 3. So that positive 3 by negative a third gives us negative 1 for 2 perpendicular lines. Now, with the gradient, we can automatically write the equation for line 2 in the form y equals to mx plus c, because we have m and we have c. So y equals to m is 3 and the y-intercept is 3. The two lines are sharing the y-intercepts. They are sloping differently, but they are both meeting at the y-intercept because they meet at x. So they share that coordinate. The y-intercept for line 1 is also equal to the y-intercept for L2. So we just need to include. And finally, let's talk about parallel lines. Draw two lines with the following gradients. All right. Lines with the gradients. Lines with these gradients. It is good for you to discover something. It's good for you to discover something. If we draw two lines with a gradient of a fifth, those two lines will not meet anywhere. Two lines with a gradient of a 2, they will not meet anywhere. Two lines with a gradient of negative 2 will also not meet anywhere. Two lines with a gradient of 5 will also not meet anywhere. Therefore, we can draw a conclusion that if lines are parallel to one another, their gradients are usually the same. You should have noticed that the lines with the same gradient are parallel. Lines with the same gradient are parallel. If line L1 has gradient equivalent to M1 and L2 as M2, such that gradient 1 equals to gradient 2, then line 1 is parallel to line 2. Line 1 is parallel to line 2. So 2 parallel lines will share a gradient. Actually, the reason why they can't meet is because they are sloping equally. If they slope differently, they are likely to meet at some point. All right? Good. Determine which of the following pairs of lines are parallel. Do not draw the line. Just examine the gradients. Look at this. Gradient is a half. Gradient is a half. Parallel. 2 parallel lines. Look at the second equation. If you rearrange this equation, if you rearrange this one, the first one you remain with 2 over 3y equals to 3 over 2x, but now negative minus 3 over 2. Yeah. So how do we remain with y? By multiplying by 3 over 2. So when you multiply by 3 over 2 all through by 3 over 2, I will get negative 9 over 4x minus 9 over 4. So the gradient is negative 9 over 4. And in the second one, can we check whether the gradient is the same? Let's check. 3 over 2y equals to negative 2/3 x minus 2/3. So we have to multiply by 2 over 3 to remain with y. So by 2 over 3, negative 4 over 9 x minus 4 over 9. The first gradient is negative 9 over 4, and the second one is negative 4 over 9. Therefore, the gradients being different, then the lines are not parallel. So this pair is not parallel. So you can continue in such a way until you determine how all the lines are related. The commonly tested format of this particular concept is now in this question 2. In each of the following, find the equation of the line through the given point and the parallel to the given line. So a line which is passing through, let me choose this one, F. Line passing through 0, 0, negative 3, and is parallel to this line. So we first arrange the provided equation such that we begin with y equals to negative 2x minus 3. When it is arranged in this way, gradient y can be extracted there, negative 2, and the gradient 2, because they are parallel, will also be the same. So that is now the secret. The gradient is going to be the same. If it is the same, it's also negative 2. Now, a gradient of negative 2, and the line is passing through 0, negative 3. It means negative 3 is our y-intercept. So this particular line, we will not struggle. Just write it negative 2x, and we write negative 3 here because it is our y-intercept automatically, the y-intercept. So that is those are the concepts actually on gradient and equations of straight lines. Our consultation line 070415 3366. That's the line you can consult us through. Let's check one serious questions here. This question is from almost all the concepts. So let's check what it talks about. A straight line L, whose equation is 3y minus 2x equals to negative 2, meets the x-axis at R. Determine the coordinates of R. Meeting the x-axis means the x-intercept, right? The x-intercept. Therefore, what will be the x-intercept? You know, the x-intercept is the coordinate or the value of x when y is 0, because along the x-intercept, along the x-axis, the value of y is usually 0. Therefore, when y is 0, what are we going to get as x? 3, 0 minus 2x equals to negative 2. So negative 2x equals to negative 2x equals to 1. So R will be written as 1, 0, because this is the point where the value of y is equivalent to 0. So people are supposed to be very careful with x-intercept and coordinates of r. Those are different questions. If we had been told to determine x-intercept, then we can say x-intercept is equal to 1. Just write it that way. But now we need it as a coordinate. So you write 1, 0. Good. Part B. A second line, L2, is perpendicular to L1, the L1 up there, at point R. So L2 is passing at point R. Find the equation of L2 in the form y equals to mx plus c. So we have to talk about now gradient of L1, 3y equals to 2x taken to the other side minus 2. So I'm rearranging the equation now. The value of y will be 2 over 3x minus 2 over 3. So can we say that gradient of line 1 is 2/3? And this can make us conclude the gradient of L2. They are perpendicular, and therefore their product is supposed to give us -1. Therefore, this other line must be -3 out of 2. So that when we simplify -3 over 2 by 2/3, we automatically get -1. So with the gradient, and we have the coordinate here where the line passes, we can get the equation -3 out of 2 equals to y minus 0, x minus 1. Let's do a cross multiplication. 2 by y, 2y. -3 by x, -3 by -1, +3. So the value of y equals to -3 over 2x plus 3 over 2. This is now the equation in the said format. All right. Part C. A third line, L3, passes through -1 and is parallel to L1. Parallel to L1. Find part 1, the equation of L3. So gradient of L3 is going to be equivalent to gradient of L1. So this is going to automatically be 2/3. For two parallel lines, their gradients are usually the same. That is something you must know. For two parallel lines, their gradients is usually the same or equal. Therefore, if M1 was 2/3, then the gradient for this third line is also going to be 2 out of 3. Now we are also given a coordinate where the line passes. So we can now talk about the equation. 2/3 being equal to, we pick another coordinate xy, so y minus 1 out of x minus -4. So minus -4 becomes +4. A cross multiplication will give us 3y minus 3 equals to 2x plus 8. So 3y is equivalent to 2x plus 11. 2x plus 11. So to remain with y, we have 2 over 3x plus 11 out of 3. I've divided through by 3. That is the equation they want. Find also the coordinates. Find the coordinates of S at which L3 and L2 intersect. The point of intersection of two lines. Do you remember in Form 1, when you were talking about graphs of straight lines, you said in case two lines are drawn, they will intersect and they give us the simultaneous solution to the respective equations of those lines. In this level now, we are talking of without plotting the lines. The equations are already known. So we can calculate the simultaneous solution of these 2 points. So when we get x and y, then when we get the value of x and also y, we write them as a coordinate, and that will imply their point of intersection, because if they were drawn, they would meet at xy. So let's look at the simultaneous solution of L3 and L2. L3 is already up here. L3 is here. What about L2? Equation of L2 is also here. So y has been expressed and y has also been expressed. So the quickest method that will help us will be substitution method. Negative 3 over 2x, negative 3 over 2x plus 3 over 2 equals to 2 third x plus 3 over 11, 11 over 3. 2 third x plus 11 out of 3. Yeah, so we just equate and we solve for the value of x. So now from combining x, I'm having 2 over 3 plus 3 over 2. This is giving me 2 and 1 over 6x. What about y? I pick 3 over 2 and I subtract 11 out of 3. And this will give me negative 2 and 1 over 6, which means the value of x will be negative 1. If the value of x is negative 1, then we can substitute x in any of the equations like here for me to get y. So the value of y will be, when we substitute negative 1, we will be having 2 over 3, negative 1, plus 11 over 3. What am I going to get? Negative 2 over 3 plus 11 over 3. This is going to exactly be 3. Therefore, if x is negative 1 and y 3, then the coordinate of S, the point of intersection, be negative 1, 3. That is the point of intersection. Remember, you can appreciate these programs by simply using the M-Pesa number 07 04 15 33 66. The same number you can use for consultation and also to request for revision materials. Thank you so much for following. Subscribe and share. Yeah, subscribe and share.